Okay, guys, welcome back. I hope you had a great week off from school and from e-learning. And I know that I am back, super happy to be back and doing some math. I miss all of you and I wish we were in person, but for now we'll just be doing videos and a combination of activities. So why don't we go ahead and get started. We are still in packet number 3, okay? And we are on, if I can get this to work, page 50, okay? And as you recall, we are doing systems of equations right now, okay? So we're going to get back in the swing of things. Again, we're on page 50, and we are in packet number 3, okay? So let's first talk about the summary of the ways we've learned to solve systems of linear equations so far in this unit. We've done a little bit of graphing, and we can remember, I think, that it's a good visual, and that's why we do graphing. On the other hand, as you probably recall, it's very imprecise. If you don't use that straight edge and you don't get that intersection point exactly right, you are not going to have the correct point of intersection in the solution. But when do we use it? When we need a visual. Okay, so that's graphing. That was week 1. That was when we were still in school, okay, actually in the building. Second thing we did right before we broke was substitution, okay? And we know that its advantages are that it can be easy to do. Okay, so that's the advantage. The disadvantage is doing it when the coefficient, let's see if I can actually spell this time, if the coefficient of the variables doesn't equal 1. And I should say doesn't equal positive or negative 1, okay? So we know it's super hard to do, and I apologize for all that noise. That would be my dog in the background, okay? And when we use this, we use it when the coefficient of a variable is 1. We'll say is positive or negative 1, okay? And that's when we do that, okay? Okay, moving right along. Today we are moving on to solving using linear elimination. Okay, now depending on what school you go to next year, what teacher you have, sometimes people call this linear combination. Okay, either one works, doesn't make a bit of a difference, but you need to make sure that you remember that those two are exactly the same thing. Okay, and our goal or objective is to add or subtract the like terms in the system of linear equations to get one variable to eliminate, okay? Or cancel, or sometimes you can say, or to drop, okay? We can say, or drop, so that we have only one variable left, and that's been the goal all along, to get one variable by itself, okay? Let's go ahead and let's flip to page 51. Okay, so here we say, example 1, solve the following linear system using linear elimination, okay? First thing I always do, we have a system, so we're going to use that fancy little bracket, okay? You're going to find that when you're doing elimination, you want it to be in either standard form, okay? Or sometimes slope-intercept form, but most of the time standard form, slope-intercept form, okay? And you can remember standard form, if we can make that up here, is ax plus by equals c. And we know that slope-intercept form is, sorry, I'm sitting at my dining room table, and my dog is under the table, and he's eating something he shouldn't be, so I had to grab that real quick. Okay, so there's slope-intercept form, there's standard form. Okay, step 1, let's use a different color. Write the system so that like terms, or terms with the same or opposite coefficients are lined up vertically, okay? And here we can see that we don't have to do anything because 6y and negative 6y are opposites, and they're already lined up. So you can see this. We have our x terms lined up, we have our y terms lined up, and then our leftover constant, okay? So we're good there. Step 2, we are going to add or subtract the equations. Again, our goal is to eliminate one variable, okay? So this is super important. You can see that I copied down the equations here, okay? Now, this is called linear elimination or linear combination, okay? So what you're gonna do, and this is super important that you always do that, you put the parentheses and you're gonna add them up. You're gonna add vertically. So 4x plus 3x equals 7x, okay? 6y plus a negative 6y, those cancel out. You're left with 32 plus 3 is 35. And you can see that that y term eliminated, which is absolutely our goal here, okay? Then you can just go ahead and solve. Divide by 7, and we get x equals 5, okay? And the one thing I should have mentioned that I didn't is if you look up here, none of the coefficients are 1 or negative 1. So that makes substitution not the most efficient method. That's why we have to have this other method. And I think that you're going to find, and we always find this every year, we always laugh about it, is that once you get to linear elimination or combination, you're not going to want to do any of the other methods. This is by far the easiest and most efficient method, okay? So now we have 1, and now step 3 is just like what we've been doing in the past. We're going to substitute the value from step 2 into one of the original equations and solve for the other variable. Here we solved for x, so now we have to solve for y, okay? It doesn't matter which equation you do unless one of them's funky or something. I just pick the first one typically. So I've got 4x plus 6y equals 32. That was one of my originals, okay, original. And I'm going to plug that in. 4 times 5 plus 6y equals 32, okay? I'll go ahead and solve. 20 plus 6y equals 32. I'm going to subtract 20 from both sides. I get 6y equals, what is that, 12? Divide by 6. We get y equals 2. Okay, so now you can see from my solution, which we always write as an ordered pair, okay, we have our x value is 5 and our y value is 2. And there's my solution, okay? And like we always do, we check our solution. We just go back to the original equations. We've got 4x plus 6y equals 32. We've got 3x minus 6y equals 3. And remember, here's your x, here's your y. I'm just going to plug those in. So I've got 4 times 5 plus 6 times 2 equals 32. We want that to be a true statement where both sides equal each other. 20 plus 12 equals 32. And we've got 32 equals 32. Okay, so one side worked. I'm sure this is the right answer. I think the other side's going to work. Remember, we want both sides to be equal. And 3 does, in fact, equal 3. So that checks, and so our solution was, in fact, correct. Okay? Let's go ahead and let's flip to page 52. Trying to keep this video under 20 minutes. We'll see what I can do. Let's go ahead and look at 1B. Okay, again, we have a system, so we put our fancy little bracket on there. Our first step is to make sure our x's and our y's are lined up, and they are. Okay, so I'm going to go ahead and I'm going to rewrite these. Okay, and then I've got 7x plus 3y equals negative 5. Okay, I'm going to go ahead and I'm going to add these. Remember, you're adding the bottom to the top. I always put this in terms of addition. Okay, and then I add up and down. So we've got 4x plus 7x, which is 11x, negative 3y plus 3y. Oh, that's perfect. They cancel out. Okay, and then we get equals negative 55. Negative 50 plus negative 5 is negative 55. Okay, I'm going to divide by 11 on both sides. X equals negative 5. Okay, there's my x value. Now I'm just going to take that and I'm going to substitute it back into one of the originals. For my purposes, I usually do the first one just for consistency. 4 times negative 5 minus 3y equals negative 50. Okay, I'm going to get negative 20 minus 3y equals negative 50. Add 20 to both sides. I'm running out of room. Negative 3y equals, sorry, I lost my train of thought for a second. I'm going to divide by negative 3. I get y equals 10. So my solution for this problem is negative 5 comma 10. Okay? And there you have it. So I think you're really going to find, once you get the hang of this and get some practice in, that you're really going to like linear elimination. Okay? Let's flip over to 1e. Okay? And we've got 2m minus n equals negative 2. And we've got negative 2m plus 4n equals 23. Okay, so again, I make sure that my m's are lined up, my n's, and my constant. We're good to go. I'm going to go ahead. I'm going to copy these down. 2m minus n equals negative 2, and I'm going to add vertically. Make sure, guys, for our purposes, we're always going to put that plus, and we're always going to put those parentheses, otherwise we lose points, okay? Your teachers next year in high school are going to be super duper strict about that. So we're going to be as well. Okay, I'm going to add down. Those cancel, nice. Negative n plus 4n, that's like a 1. So that's going to be 3n. Negative 2 plus 23 is 21. Divide by 3, and we get n equals 7. Okay? Now, we are going to go ahead and plug that in. Again, like I said, I usually use the original, the number 1, but you don't have to. So we're going to do, let's get a red pen here. We're going to do 2m minus, and then we have a 7, so minus 7 equals negative 2. I'll add 7 to both sides. I get 2m equals 5. Don't freak out if you see a fraction or a decimal. We're going to get those sometimes. And you get 2.5 or 2.5. I don't care which one you do. And then we're going to do, and remember, always in alphabetical order. Okay, so my m is going to come first. 2.5, comma, 7. And there you have it. Okay. I think it's not that difficult once you've done some, like I said. Now, of course, though, they're going to get a little bit harder. So let's go on to page 53 and see what the next step is, okay? Let's add to it. Okay, we're on page 53. Okay, example 2, solve the system. Okay, let's just think about this for a second. What do we notice? Well, what I notice right away, my x's are lined up, my y's are lined up. I'm good from that standpoint. But what I do notice is that those are not opposites, okay? Not opposites. None of my variables are opposites, okay? So what that means is that we're going to have an extra step in here. Okay, so write the system so that like terms or terms with the same or opposite coefficients are lined up vertically, okay? Well, if we look at that, that's done. X's, Y's, we're good. Okay, step 2. The same or opposite. Okay, so let's talk about that for a second, okay? If you were to add down the way it is, 7 plus 8 is 15. 2 plus 2 is 4. 24 plus 30 is 54. Nothing cancels, okay? So this is what you're going to do. I always take equation 2. Okay, I'm going to take it down here. I'm going to do 8x. Oopsie, that's supposed to be an 8. 2y equals 30, okay? I need to get so that those are opposite. So what I'm going to do is I'm going to multiply this whole thing times negative 1, okay? And that's going to give me, all of my signs are going to be opposite. Negative 8x minus 2y equals negative 30, okay? I didn't change the equation because I multiplied both sides. Remember, if you do it to one, you have to do it to the other. So I multiplied everything by negative and watch what happens. Copy down your first equation. 7x plus 2y equals 24. Okay? Copy down your second equation. Negative 8x minus 2y equals negative 30. Look what happens. We've got some opposites there. Okay? We can add these like we always do now. 7x minus 8x, negative x. These cancel. Equals, let's see, what's 24 minus 30? Negative 6. Okay, I can't have a negative variable. Divide by negative 1. X equals 6. Okay, because remember, our goal is to eliminate a variable. We want those to be opposites. Okay, so here, my step was we add or subtract the equations with the goal of eliminating one variable. Okay, that's the goal in all this. So if we look at step 3, now it's just back to what we know. We're going to substitute the value from step 2 into one of the original equations. Remember, it doesn't matter which one, and solve for the other variable. Okay, so I'm going to take my first one, 7x plus 2y equals 24. I'm going to take that and plug it in there. 7 times 6 plus 2y equals 24. You get 42 plus 2y equals 24. I am going to subtract 42 from both sides. I get 2y equals negative 18. And I get y equals negative 9. Okay? So write the solution as an ordered pair. I'm going to get 6 comma negative 9. Okay, and our last step, I'm just going to warn everybody right now. My dog is scratching at the door, which means he's going to start howling soon. So if it gets really loud, I apologize. That's why. I am the only one in my dining room right now, and my kids are not around. They're in the basement. Jack, come here. You want to see everybody? Guys, we'll take a break for a sec. Come here. Come here. Let's see. Come here, buddy. You guys want to see my dog? I know I always talk about him. Let's see. Let's see if you guys can actually see. Oh, well, he does not want to be on camera right now, obviously. So never mind. We'll try it again later. Okay, check your solution. We are going to go ahead, and I want you to do this. You do on your own. Okay, sorry about that. That absolutely did not work with the dog. I thought he might enjoy being on the camera, but he obviously doesn't. Okay, we're going to turn to page 54. We're in the home stretch here. We're at the 15-minute mark. Let's try 2C, okay? We're on page 54, 2C, and we're going to put our fancy little bracket because we're doing a system, okay? And let's look at these for a second. Now, right away, make sure they're all lined up, okay? We can see that we have our X's and our Y's and our constant, so we're good there. The problem is that, remember, we want to eliminate. If we add vertically, -3 plus -3 is -6. That's not going to work. So I always take my second equation and I multiply it by -1. Okay? And what that's going to do, there we go, it's going to give me opposites. So we get 3x plus 9y equals 42. Okay? Oopsie, it'd help if you could see. Okay, so now watch what happens. We get, right, our first equation, -3x minus 6y equals -18. Okay, now we're going to write down our second equation that we got. 3x plus 9y equals 42. And look at that. Now we have opposites. I'm just going to write that. That's what we want. We want to see opposites, okay? So now I'm going to add them. Let's get a pen here. We add vertically. -3 plus 3 is 0. They cancel. -6y plus 9y is 3y. And -18 plus 42 is going to be 24. Okay. Divide by 3. And we get y equals 8. Excellent. Okay. Now we have our y value. Now we're just going to substitute into the original. Either one. I'm going to take the first one. We've got a -3x minus 6 times 8 equals -18. That's -48. Add 48. We're just solving for x. We get -3x equals, oh, look at that. That's nice, 30. Divide by -3. Get x equals -10. So my solution is x first, -10, comma, 8. Okay, so that's how we do those kinds of problems. Let's see how much we've left here. Oh, we're in the home stretch. I can do a couple more. Okay, let's go to 2D. Okay, I feel like this is kind of, make sure that's all focused for us so we don't have to, let's see if that can autofocus. Oh, much better. Okay, 2D. Okay, again, we're adding vertically. We have no opposites here, okay? 2 plus 2 is 4. -3 plus, okay, so it's going to give us y. It's not going to work, so we need opposites. Okay, so I'm going to go ahead, and I always multiply by my, I just do the second one. It doesn't really matter. I always do the second. Times -1. Okay, that's going to give me -2x minus 4y equals -21. Okay, so let's rewrite these. We've got 2x minus 3y equals 14. I'm going to bring this one down. -2x minus 4y equals -21. Oh, look at what happens. Okay, those cancel. We're good to go. -3 plus -4. We've got a -7y. 14 minus 21, -7. Divide by -7. And I've got y equals 1. Okay, now we're going to substitute back into the original. So I'm going to take the first one, doesn't matter which. 2x minus 3 times 1 equals 14. Add 3. We get 2x equals 17. Don't freak out if you get a decimal or a fraction. It's okay. And if you don't believe it, just put them back in and check. X equals, what is that, 8.5 or 8.5? Or 8.5, I don't care which. And we are going to go ahead and write our solution. What is that? Let's do a decimal. 8.5, comma, 1. Okay, and you're good. You're good. Okay, last kind of type, if you will. Let's turn to page 55. Okay, we have one more type of problem to do. Okay, system, fancy bracket. Now, look at this. We're not in standard form. We're not in slope-intercept, so not in standard form. Okay, so step 1, standard form. You got to get it in standard form or slope-intercept so they're all lined up, okay? I want to line up my x's. I want to line up my y's. I want to line up my constant, okay? So I'm going to write down that first, let's see, this one's already in standard. Let's do our second one. 7x equals 2y minus 31. So you want to get it into standard form. I'm going to do that by subtracting 2y on both sides. I get 7x minus 2y equals negative 31. Look at that. I'm golden. I'm in standard form. Okay, so go ahead and let's say step 2, align equation. And all I mean is line up your x's, line up your y's, line up your constants. Okay, so we've got 7x plus 3y equals negative 6. And then we're going to do this one, 7x minus 2y equals negative 31. Okay, now I need those to be opposites so they cancel or eliminate. Okay, so I'm going to multiply that second equation times negative 1. And I get negative 7x plus 2y equals 31. Okay, rewrite. First one, 7x plus 3y equals negative 6. Then I'm going to do this one. Negative 7x plus 2y equals 31. I'm going to add them. Cancel. We get 5y equals, what's negative 6 plus 31? That's 25. Divide by 5. And we get y equals 5. Okay? So that was not so bad. Now we're just going to substitute. We're going to substitute. Okay? I'm going to take my first equation. 7x plus 3 times 5 equals what? Negative 6. Oopsie. Plus, I can't write today, equals negative 6. Subtract 15, I get 7x equals negative 21. X equals negative 3. So my solution is negative 3, comma, 5. Okay. I feel like we've done a lot. Oh, let's talk about the standard form. AX plus BY equals C. And y equals mx plus b. But we're typically going to be in standard form, okay? Let's turn to page 56, okay? 3b. Again, we're not in standard form and we need to be, okay? We need to be in standard form. So I'm going to go ahead and this one right here, not in standard form. So rewrite it. I'm going to subtract 9y from both sides. I get 5x minus 9y equals 103. I want to get it in standard form. Okay, now I am. So I'm going to rewrite. I've got 6x minus 9y equals 111. And I've got what? Down here, 5x minus 9y equals 103. Okay, here's the problem. We don't have, and we want opposites. Okay, we want opposites. So I'm going to have to multiply that second one by negative 1 so they cancel out, okay? I get, we're just going to share some space here. I get negative 5x plus 9y equals negative 103. Okay, let's line those up. 6x minus 9y equals 111. Then I've got negative 5x plus 9y equals negative 103. Let's add those up. Okay, vertically, I've got x, cancel, equal, what is that, 111, 103, that's 8. Oh, that's nice. I don't have to do anything else. X equals 8. Then I'll go over here. I'm going to sub. So I've got 6x, 6 times 8, minus 9y equals 111. Oh, let's see. 48 minus 9y equals 111. Subtract 48. We get negative 9y equals, what is that, 63, I believe? Y equals negative 7. So my solution, it would have helped if you could have seen that, sorry about that, is 8 comma negative 7, okay? Now, I was going to do one more problem like this. I'm not going to in the interest of time. However, I do want to quickly, if I can find them, turn, and of course I can't, turn to page, look at my notes here. Sorry about that. Well, I was going to do some, but if I can't find them, you guys might be off the hook. Let's see about that. Oh, they're in this. Never mind. You're not off the hook. Okay. Let's look at page 64. Okay, still in the same packet. And I want you to look at problem 2. I'm not going to do this whole thing, but I want to set it up so we have an idea of how to do a word problem, okay? It says, I am thinking of 2 numbers. Negative 3 times one number plus 5 times the other number is negative 11. 3 times the first number plus 7 times the other number is negative 1. Find the numbers, okay? This is not as hard as it first looks. Define your variables. First number, second number. That's all it says. We've got 2 numbers. I think these are kind of fun because they're kind of like a puzzle. Write the system. Okay, I go through the words. Negative 3. Write it. Negative 3. Times one number. Okay, well, let's say times x. Plus, so plus 5 times, okay, 5 times the other number is this equals, okay, so equals negative 11. And you've got your first equation. Second one, 3 times the first number. Well, we said the first number was x, 3x, plus 7 times the other, so 7y is equals negative 1. And then we're just, oh, and look at that. Those are opposites. Oh, that's fantastic. We can just go ahead and cancel those out. We can add them, etc. Okay, you do. Okay, so that's one setup. The other setup I just wanted to talk about quickly is number 7. Okay, Holly purchased 2 pairs of shorts and 5 shirts for $243. Her pal Stephanie purchased 2 of the same, this is page 65, 2 of the same pairs of shorts, but only 2 of the same shirts for $162. What is the price of the shorts? What is the price of the shirt? So we're going to say X is price shorts, and Y can be price of shirts. Okay, I'm just going to set it up. I'm not going to solve it. We're going to do our system. Okay, so we know that 2 pairs of shorts times whatever price, we don't know, plus 5 shirts, we don't know how much, plus 5Y is going to be $243. Okay, you can use your dollar signs, etc. And then we know that Stephanie purchases 2 of the same shorts, so 2X. 2 of the same shirts, but we don't know the price, so 2Y. And she spends $162. Okay, and then we're going to solve by multiplying by negative 1, etc. Okay, so that's my setup. I think that's plenty. I went a little over. I apologize. And as always, if you have any questions at all, email me about anything. You can always email me. We can do a Google Hangout or what do you call it, a Google chat or Hangout. So I'm always available. Okay.